Gravity is a fundamental force that governs the motion of objects in the universe. It's an invisible force that pulls objects towards one another. Despite being one of the weakest forces, its effects are profound and far-reaching. At its core, gravity is the force that keeps planets in orbit around the Sun and moons in orbit around their planets. This invisible force is what gives weight to physical objects and causes them to fall towards the ground when dropped. Sir Isaac Newton was the first to mathematically describe gravity in 1687. He proposed that every mass attracts every other mass with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This became known as Newton's law of universal gravitation. Later on, Albert Einstein expanded on Newton's ideas with his theory of general relativity. According to Einstein, gravity is not just a force but a curvature in space-time caused by the presence of mass. Imagine space-time as a stretched rubber sheet. Any mass placed on it causes the sheet to warp and other objects move along these curves, which we perceive as gravitational attraction. Gravity doesn't only affect planets and stars, it also governs the behavior of galaxies and even light. This effect, known as gravitational lensing, can bend the path of light as it passes near a massive object. Such phenomena allow astronomers to study objects that are otherwise too distant or faint to observe directly. On Earth, gravity is the reason why objects stay grounded. It gives us our sense of weight. Every object with mass exerts a gravitational pull, but Earth's mass is so large that its pull dominates our everyday experiences. This is why when you jump, you're pulled back down to the ground. Interestingly, gravity also varies slightly across Earth's surface due to factors like altitude and the distribution of Earth's mass. For instance, gravity is slightly weaker at higher altitudes or over large mineral deposits. These variations are so small that they're generally imperceptible in daily life. Understanding gravity has not only shaped our knowledge of the universe but also advanced numerous technologies. Satellites, for example, rely on precise calculations of gravitational pull to maintain their orbits. GPS systems use these satellites to provide accurate positioning on Earth, revolutionizing navigation. In essence, gravity is more than just a force pulling objects downward. It's a crucial component of the universe's structure, influencing everything from the fall of an apple to the complex orbits of celestial bodies. Its study continues to reveal the intricate and interconnected nature of our cosmos,